So let's do an example. This is a pendulum with a mass of 900 grams and a length of 65 centimetres. It is pulled out at an angle of 38 degrees from the vertical. This obviously took work to do this, and this now has got potential energy. I want you to determine the gravitational potential energy in the pendulum, and then I want you to determine the maximum speed of the pendulum as it passes the vertical when it's released. So what maximum speed will it have? That's what we need to work out. So how do we determine the gravitational potential energy? Well, this is the formula, E equals mgh. Now, first of all, we need to identify the height that the pendulum has been raised to, put in the formula, because to put this formula we need the h. Well, we need to work out the height it's been raised to in the formula. Well, I've used trigonometry, as you can see this. We need to know the height from here to here. We know that the height from here to here is 65 centimetres. Therefore, we need to take away the length of A, this A, to give us the height here. That's what we need to work out. We know that's 65 centimetres. We need to work out what A is and then take it away from 65 and we'll know what H is. Yeah? Right, using trigonometry, we know the hypotenuse and we know we need to determine the length using SOHCAHTOA. We use the cosine function. Cosine 38 equals the adjacent divided by the hypotenuse. Cosine of 38 is 0.788. If you transpose this, A there, comes out at 51.22 centimetres. So we know what that part is, A there. Therefore, the height that we're trying to find out is 65 minus 51.22 is 13.78 centimetres. That pendulum is 13.78 centimetres above the datum. Now we've got the height, we can insert all known data in the formula, E equals mgh, put them in, it multiplies it out, it gives a potential energy of 121.66 joules. That is the potential energy that ball that has got, that pendulum. Let's cover part B. How fast is the ball travelling as it passes the vertical? Well, what you're saying is to determine the speed at this point when all the potential energy is converted to kinetic. Do you understand? At the point where it passes the vertical, all the potential energy will be converted back to kinetic. All of it. So that's the maximum speed. This means mgh equals half mv squared. Do you understand? Now we know the potential energy is 121.6. That must mean it equals half mv squared. Now we put the mass in, put the known variables in. You can transpose this out. As you can see there, transpose it. You get 121.66 divided by 0.45 equals v squared. Therefore, put that in the formula, multiply it out. It gives you a velocity of 16.44 metres a second. This allows you to work out that potential energy, you let it go, what velocity it will be travelling, because all the potential energy has gone to kinetic energy, and it works out the velocity of that at that point will be 16.44 metres a second. And as it goes past that, it'll start to slow down as it transfers that energy back into potential energy. Let's just summarise what we've worked out. We've worked out if you get a pendulum and you lift it out, you have raised it above the datum where the bottom is, you've raised it, you get potential energy. You can work out that potential energy, and then when you let it go, all that potential energy will turn into velocity energy. And at the point it reaches the bottom, that is when all the potential energy has been turned into velocity energy. As the ball goes past there, it starts to go back up again, and some of the velocity energy will be converted back to potential energy. So halfway up, it's got some velocity energy, but it's also got some potential energy. And then when it stops, when it gets to a point it stops, then all the potential energy is there, and there's no kinetic. Do you understand? All the way it's transferring potential to kinetic, and then kinetic to potential. Halfway through, it's got a bit of both. Energy can only be transferred. You are going to lose some due to air resistance, but it's negligible. If you left that pendulum going because of air resistance, it would carry on, but it would slow down because it would lose some energy to heat, and that will be transferred in the pendulum.